Okay, so unless you've been living completely off-grid, you've seen AI just change everything. It's in your pocket, it's at your job, and now, yep, it's making its way into the science lab. Today, we're diving into what happens when two of the most mind-blowing frontiers, artificial intelligence and space exploration, finally collide. This is the story of AI's promise to completely rewrite our understanding of the universe and the pretty uncomfortable truth that tags along with it.
So, what's on the docket? First up, we'll see how AI is basically becoming this new kind of research assistant. Then, why we're drowning in so much cosmic data that it's impossible for humans to handle. We'll get into AI's superpower as the ultimate pattern finder. And then, this is where it gets weird. We'll look at how it's becoming a kind of alien genius. But, and this is a big but, we have to talk about the uncomfortable truth, the black box problem. Finally, we'll see how we can reframe all this and think of AI not as a scientist, but as humanity's newest and most powerful telescope.
I mean, it was bound to happen, right? With the explosion of things like large language models, AI is popping up everywhere you look. And that absolutely includes fields like physics and astronomy. And that, of course, leads to one heck of a question. Can an algorithm, a piece of code, actually be a scientist? That question gets right to the very core of what science even is. And the answer we're starting to find is, well, it's a very complicated yes. AI is already helping us tackle questions we thought were totally unanswerable. But to really get how it's doing that, first, we need to understand a problem of truly cosmic proportions.
To really wrap your head around why scientists are so eager to bring AI into the fold, you have to appreciate the just insane scale of the universe they're trying to map out. And it all kicks off with a great little story about one scientist, one telescope, and one incredibly lucky find.
So, right after the new Euclid telescope went online in 2023, a scientist named Bruno Altieri was just, manually looking through the first images. And he spots this tiny little fuzzy thing. Well, that fuzzy spot turned out to be an unbelievably rare cosmic event. But here's the wild part. He found it in a data set that had 100 million other light sources in it. I mean, that's not finding a needle in a haystack. That's finding a specific needle in a literal mountain range of haystacks. So what was this thing he found? He'd found an Einstein ring. And the craziest part is, this ring isn't even a real object. It's a cosmic mirage. Just imagine a huge galaxy acting like a giant magnifying glass in space. Its gravity is so strong, it actually bends the light from another galaxy that's perfectly lined up behind it, creating this beautiful ring. And by measuring that distortion, scientists can weigh the galaxy in the front. And if it weighs more than all its visible stars, well, that invisible mass, that's probably dark matter. Altieri's super lucky find really just highlights the problem, doesn't it? He found one ring, but the full Euclid mission, it's expected to create hundreds of petabytes of data. It's a number so ridiculously huge, our brains can't really even process it. Just to put that into perspective for you, one single petabyte is 1,000 terabytes. Storing all the data from Euclid would be like lining up nearly 1,000 high-end computers. We know for a fact there are thousands more of these priceless Einstein rings hiding in that data, but asking a human to find them all, it would literally take generations. And this is where AI steps in. This is what AI was born to do. It is, without a doubt, the ultimate pattern finder. It's able to sift through those cosmic haystacks at a speed no human could ever hope to match. And it's not just looking for those perfect, rare rings. Yeah, because Euclid's main mission isn't even finding those obvious, perfect rings, what's called strong lensing. Now, it's hunting for something way subtler, weak lensing. Try to imagine looking at millions of galaxies and spotting the tiniest, almost imperceptible way their light is being warped by the gravity of a huge galaxy cluster in front of them. It's like trying to hear a statistical whisper in a hurricane. It is completely impossible for the human eye. You need a machine. And look, machine learning already has a super impressive track record. It's already identified dozens of new potential gravitational lenses. It's cataloged over 400,000 new galaxies with near-perfect accuracy. It's even found brand new planets hiding in old telescope data. It is an absolute master at finding patterns. But what happens when it goes beyond just finding patterns and starts creating them? Okay, this is where things start to get really wild. We're now moving past AI as just a data cruncher and into the territory of AI as a creative partner, one whose mind works in ways that are, well, truly alien to ours. Take the LIGO experiment, for example. It's this incredible project that listens for the faint whispers of gravitational waves in spacetime. To make their detectors even more sensitive, they set an AI called Urania on the problem. At first, the designs it came up with were just nonsense. But then, it started spitting out these bizarre, totally alien-looking solutions that actually worked. They boosted sensitivity by a lot. But here's the catch. The human scientists were totally baffled. They had no earthly idea why it worked. It took them months of work to reverse engineer the AI's logic, only to find out it had brilliantly rediscovered a scientific principle they had completely forgotten about. And that story, right there, leads us straight to the other side of this whole thing, the uncomfortable truth. Because for all of its incredible power, AI also brings the danger of the black box, getting the right answer but having no idea how you got there. Because really, science isn't about just getting the right answer. It's about understanding. An answer that comes out of a black box, a solution that comes with no explanation, it's just a number. It's not knowledge. And even worse, if we can't follow the logic, how can we ever really, truly trust the result?
And believe me, the scientific community is wide awake to these dangers. A poll in the journal Nature found that huge majorities of scientists are worried about AI spreading misinformation, hiding plagiarism, or just baking mistakes right into the research. And there's another really big concern. Since AI learns from our human data, it might just end up reinforcing the biases we already have.
And we're not just talking about hypotheticals here. The Royal Society is already demanding that we put safeguards in place to stop AI from contaminating or even just making up data. And while the number of research papers using AI is going through the roof, so is another really worrying trend. More and more studies that are impossible for other scientists to reproduce. I mean, that's an attack on the very foundation of the scientific method. So, where do we go from here? How do we move forward? Well, the solution might be to stop thinking of AI as some kind of robot scientist and start thinking of it as a new kind of scientific instrument. A tool that, like any powerful tool, needs a human hand to guide it. This is the key. This is the big mental shift we need to make. AI is not a replacement for the scientist. It's a new kind of telescope. It's this incredibly powerful tool that can scan the entire sky at once and basically tell us, hey, look over here, this part is interesting. It's there to direct our uniquely human curiosity, our skepticism, and our deep, deep drive to actually understand. So this is the new deal. This is the trade-off. AI gives us the power to see the biggest picture we've ever seen, to find patterns in data sets so enormous, no human could ever get through them. And the price we pay? We have to accept that its findings aren't always going to be perfect, and that going back to verify them is a huge job. It's a trade. We're giving up a tiny bit of certainty for a giant leap forward in discovery. Ultimately, what AI really is a mirror. It's reflecting our own data back at us, but in a way that lets it spot patterns we're just too slow to see. It is an amazing, incredible tool for discovery, one that can show us what is out there on a scale we never even dreamed of. But the real question, the one that will define the future of science, is this: can it ever truly help us understand why?